a certain second period element has the following successive values for the ionization energies. And here is the data. What element is represented by this data? We have 5 choices here to choose from. Now let's find out the key words in this question. Second period. Okay, so which means if we look at those choices, if they are not in the second period, of course that will be automatically out of question. Then we immediately actually spotted aluminum is not a second period element, so that one is out. Now let's take a closer look at the ionization data. Okay, so from the first ionization to the second ionization energy, it increases. So from 800 to 2400, yeah, pretty large, but let's say that's threefold. And then from second to the third ionization energy, that's not even doubled, which means it relatively it is reasonable to assume, okay, this should be a group of 3A elements so far, because the group 3A would have 3 valence electrons, so it's of course relatively easier to lose the first 3 electrons, but it is really here that can confirm this speculation or this analysis, because from the third ionization energy to the fourth ionization energy, that increase so many folds, which means removing the fourth electron has to be from the core, one of the core electrons. So that's why it requires much, much higher energy. Then that further confirms this has to be an element that does have only 3 valence electrons. So, okay, now that means should be group 3A. Group 3A, and now period is the second period. So that's easy. Let's take a look. Second period, of course, this is the second period, and group 3A. 3A is right here. So it's boron in this case, of course. Then boron is the correct answer. And now let's also review the successive ionization energies. Okay, so you see for group 1A, like sodium, the first ionization energy is relatively low, and then the second one is already you have to remove one of the core electrons. That's why there's a huge jump, almost tenfold. Magnesium, that's group 2A elements. Okay, the first 2 ionization energy, the value are reasonable, but from the second to the third, you see that's also a huge jump. That's because, again, the same reason. It takes greater energy to remove core electrons. Okay, and then you see aluminum is group 3A, just like boron. Okay, so a group 3A element is relatively easier to lose the first 3 electrons, but the fourth one, you have to move one of the core electrons. So the energy jump is huge. Yeah, based on this analysis, that also confirmed our answer for this question. Boron is correct, because boron is the third group 3A, one of the 3 group 3A elements.